So today we're talking about factoring polynomials when you see a quadratic trinomial, but a is not equal to 1. Yesterday we talked about when you have a coefficient of 1 for your x squared term and how easy that was, but why it works. And now we're going to have some practice when a does not equal 1. So we are still looking at quadratics. Quadratic polynomials, remember that's when the degree is 2 and you see an x squared term. This method is for when we see a trinomial. That's 3 terms. And in this case, our leading coefficient does not equal 1. Normally, I would say you want your a to be positive. So if your a is not positive, you'll want to start by factoring out a negative and then doing our x puzzle from yesterday. So yesterday we talked about how we would set up our binomial pairs to start with x because x times x equals x squared. That's this example right here. But in this case, a does not equal 1. So you can't know exactly what you would put here for x. If this a was equal to 4, you might have x and 4x, or 2x and 2x. So you actually have to use your x puzzle to find out how you're going to break up b, and then you're going to group. So I know that can sound confusing, so we're going to do several examples. The first thing you're going to want to do is you're going to multiply a times c, and you're going to put that in your product spot. We'll be looking for numbers that multiply to make the product of a times c. You are going to use your b, same as yesterday, for your sum spot. So this is our product spot up here and our sum spot down here. I know that it might feel different than yesterday, that you would use your a times c, but yesterday when c was up here, you could still have said a times c, but a was always 1. 1 times c is c, but now you'll actually have a value there. So let's do this with our first example. Okay. So our a value is 6, our c value is negative 14. We're going to multiply 6 times negative 14, and we get negative 84. And then we have a 17 for our sum value. You are going to solve your x puzzle. Solving your x puzzle, remember you want to decide your signs, find your factors. But these factors that you find are going to be what we use to break up our b term. What does that mean? Well, let's first start with 84 and 17. I know that this is a negative 84. So I'm going to have a negative value and a positive value because they have to have a negative times a positive to get a negative. Whatever numbers I get are going to, my larger number is going to be the positive because 17 is positive. So 84. 1 times 84, 84 minus 1 is not 17. 2 times 42, 3 times 28. 28 minus 3 is 25. 4 times 21. Ooh, 4 times 21. 21 minus 4 equals 17. So 21 and 4. These are what we use to break up b. Not have to use grouping yesterday to determine our binomial factors, but today it is not optional. I take the 6x squared, still a 6x squared, but 17x gets broken into minus 4x plus 21x. and minus 14 is still there. Now we group. Out of our first group, 2x. 2x times 3x gives me 6x squared. 2x times negative 2 gives me negative 4x. Out of my second group, 7. 3x minus 2. So what we're doing here for our last step is to factor the polynomials by grouping. And I'm going to write grouping real big so you know it's not optional. So my first group and my first binomial pair, 2x plus 7, and my second would be 3x minus 2. And you can check by foiling. 2x times 3x, 6x squared. Outside would be negative 4x, inside would be positive 21x. Combine those, you get 17x. 7 times negative 2 is negative 14. Okay. Right, example 2. A, C, find your product. 9 times 2 is 18. What multiplies to be 18 and adds to be 11? Well, that's not too hard. 9 and 2. Since they're both positive, we're both going to get positive. Now, does it matter which order you put these in? Not at all. You're going to group and you're going to end up with the same answer either way. So remember that this is telling us how to break up B. So 9x squared still remains, but instead of plus 11x, I'm writing plus 9x plus 2x plus 2. And then we group. Out of my first group, the GCF is 9x, and I leave x plus 1. The GCF out of my second group is 2, so I leave x plus 1. So my factored binomial pairs are 9x plus 2 times x plus 1. In our last example, what is happening? There's an x to the 9th, but I thought this only worked when the degree is 2. We're looking for quadratics. So what you need to always be checking for is your GCF. So these have a GCF of, well, what fits into 9, 12, and 192? 3. And x to the 9th, x to the 8th, and x to the 7th. I can factor out an x to the 7th. So then we are left with 3x squared plus 4x minus 64. Okay. And now when I do my x puzzle, I'm only looking at my quadratic trinomial. The 3x to the 7th is going to hang out over here. So 3 times negative 64 is negative 192. Adding to be 4. Make your T-chart. So we've already talked how 1 and 2 are not going to work. 3 probably won't work, but if you want, we can put 3 and 64 on there. 4 times 48. 6 times 32. Still not close. I wonder if 7 fits in. I don't think so. 8 fits in. 24 times. 9 does not fit. 10 does not fit. 11 does not fit. 12. 12 times, guess what? 16. Hey, look. That has a difference of 4. So we're going to have minus 12 and positive 16. And it's positive 16 because it is a positive 4. And 16 is larger than 12. If this had been a negative 4, we would have swapped. We would have had positive 12 and negative 16. So my 3x to the 7th is still here. And we're still writing our 3x squared and our minus 64, but remember, these guys tell us how to break up 4x. So minus 12x plus 16x. These things combine to be 4x, but we need 4 terms to group. So we're grouping. And I always like to do my negative before my positive, because if I do that, then I don't have to worry about factoring out a negative here. If this is a positive and this is a positive. Sometimes you won't have that option if you have 2 negative factors right there. 3x to the 7th is still there. Coming out of my first term, or my first binomial, is 3x, and we're leaving behind x minus 4. And then guess what? In order to make this an x minus 4, I'm going to factor out 16. So x minus 4. Okay. So our final answer would be 3x to the 7th is still there, times 3x plus 16 times x minus 4. If you have any questions, please see your teacher. You can find more practice on this skill in your IXL AA5. And boom goes the dynamite. Did you like how I roasted Parker today?